Question 7. Alcohols undergo dehydration in the presence of concentrated phosphoric acid via carbocation intermediate from alkenes. Complete the mechanism of conversion of 2-methyl cyclohexanol into 1-methyl cyclohexene via carbocation D by drawing. Structure of missing intermediates, all necessary curly arrows. First thing you should know is that non-pair of electrons here bonds to the H+. Yeah? Then we form bonds to the H+. Then we form this. The H3C, the methyl and the hydrogen remain the same. But now what happens is the oxygen is positive. And what happens to the oxygen goes from here to the oxygen, not to the positive charge, and then you form this, right? And then what happens is the hydrogen wants to form the double bond, so from the middle of the H to here, and therefore you form this. So 1, 2, 3 curly arrows, and yeah, the structure of missing intermediates. 7.2 draw structure of different cyclic alkene formed from carbocation D. Well, it's just going to be CH3, but the double bond is going to be somewhere else, in this case here. Carbocation D can undergo a type of reaction called a rearrangement to form carbocation E. In this reaction, a hydrogen atom has bonding pairs of electrons move from carbon A to carbon B, as shown in figure 2. Using the knowledge of carbocation, explain how this rearrangement happens. Look at carbocation E. Well, it's changing from a secondary carbocation to a tertiary carbocation. More stable carbocation formed, changes from secondary to tertiary carbocation. 7.4 as a result of the rearrangement in question 7.3, a third alkene is formed to actually show the structure of this third alkene. But what's going to happen? Well, it's going to form a double bond. So what's going to happen is you're going to have the cyclic structure 1, 2, 3, 4, 5, 6. Double bond here, CH2. 7.5 cyclohexene prepared by dehydration of cyclohexanol using concentrated phosphoric acid. Catalyst structure of concentrated phosphoric acid is shown. Identify the factors that influence the boiling points of each of the compounds of reaction mixture, state how and explain why cyclohexene can be separated from the reaction mixture. 6 marks. So we've got phosphoric acid, which has hydrogen bonds. We can clearly see it has hydrogen bonds. So the cyclohexanol and the cyclohexene. Well, cyclohexene has van der Waals forces. Cyclohexanol will have dipole forces. Cyclohexanol is going to have hydrogen bonds as well. So stage 1, let's just state the intermolecular forces between each one. Cyclohexene has hydrogen, has van der Waals forces between molecules. Cyclohexanol has hydrogen bonds between molecules, and so does phosphoric acid, and phosphoric acid has hydrogen bonds between molecules. Stage 2, let's talk about the strengths. Well, we know therefore cyclohexene has weakest forces, as hydrogen bonds significantly stronger than van der Waals. And then stage 3, how and explain why can be separate from reaction mixture. So how? Well, it's going to be cyclohexene can be separated by fractional distillation. Why? Because cyclohexene has the weakest forces, got weak van der Waals forces compared to strong hydrogen bonds that phosphoric acid and cyclohexanol have. Therefore, it's going to have the lowest boiling point. Cyclohexene has the lowest boiling point. And what does this mean? Therefore, cyclohexene will boil off first. And that is the end of question 7.